Hello and Assalamualaikum. This is a simulation presentation for the module EEE3811 Circuit Design and Simulation. My project is the Intelligent Water Harvesting System. The circuit you see here is the fully assembled hardware prototype built on a breadboard to replicate the logic we designed in Multisim. It utilizes 74 series logic gates, which is 7404 and 7408. To automate water level detection and motor control. Okay, so to ensure safe operation for the logic chips, the system is powered by a regulated DC power supply set to 4.8 volts with a current limit of 1 ampere. This provides a stable VCC for the standard TTL and CMOS logic levels used in the design. Okay, so we begin the simulation at the low water level. Here, switch 1 is closed, simulating water reaching the bottom sensor. The red LED activates immediately. This visual indicator confirms that the tank is no longer empty and the system has begun the harvesting process. As the water rises, it triggers the second sensor. Here, both switch 1 and switch 2 are closed. You will notice the system's priority logic in action. The red low LED automatically turns off and the orange medium LED turns on. This demonstrates that the circuit correctly identifies the specific water level state without conflicting signals. Okay, so next we simulate the tank reaching maximum capacity. Currently, the water is at the high level, so switches S1, S2 and S3 are closed. However, the float sensor is not yet triggered, and as you can see, the motor indication light remains off. This means the lid remains open, allowing water to continue entering the tank. Finally, the water level rises enough to trigger the mechanical float sensor. The green LED confirms the high level and the red motor indication light activates. In the real system, this signal powers the motor to close the tank lid, preventing overflow. And so this mechanism is designed to be self-resetting. As soon as the water is consumed and the level drops below the float sensor threshold, the circuit detects the change. The motor light will immediately turn off, signaling the lid to open again. This ensures the system automatically resumes rainwater harvesting whenever there is a space in the tank. Okay, so to verify the hardware reliability, I measured the voltage states directly at the logic inputs. Here, with the switches open, the multimeter reads 0.365 volts. This is well below the 1.5 volt threshold, confirming a clean logic 0 or low state. So conversely, when the sensors are activated, the voltage rises to approximately 2.7 volts. While slightly below the supply rail due to circuit load, this is sufficient to register as a valid logic 1 or high state for the logic gates, ensuring the system responds accurately to every switch press. In conclusion, this hardware simulation successfully demonstrates the logic required for an intelligent water harvesting system. The circuit correctly identifies sequential water levels, prioritizes the display LEDs, and integrates a safety float sensor for motor control. Thank you for watching.